we continue our journey into calculus and the exploration of derivatives with some more tools for your derivative toolbox. So in this section, we are going to be trying to find the derivative of the sine and cosine function, find the derivative of the standard trigonometric functions, calculate the higher order derivatives of sine and cosine. So here's some nice derivations for these functions, but I'm going to come down to what they are. The derivative of the sine function is cosine, and derivative of cosine is the negative sine. Okay. And here's some nice proofs. So how do we use this here? Find the derivative of 5x cubed sine x. So for this first one, we have two things going on here. We have this product of 5x cubed and the sine x. So our f prime of x is going to be 5 times 3x squared times sine x plus 5x cubed times cosine x. So our derivative is 15x squared sine x plus 5x cubed cosine x. That's it. Let's try another one. Find the derivative of sine x cosine x. So again, this is a product rule. F of x, f prime of x I should say, is going to be the derivative of sine, which is cosine of x, times cosine of x, plus sine x times the derivative of cosine, which is negative sine x. So we end up with cosine squared x minus sine squared x. Okay. Let's try another one here. Find the derivative of y with respect to x for y equals negative 6x minus cosine x. So our derivative of negative 6x dy dx is going to be negative 6, and the derivative of cosine is negative sine x. So this becomes negative 6 plus sine x. Here's another one. There we could use the quotient rule. So our g prime x is going to be low, which is 4x squared, d high, which is negative sine x, minus high, which is cosine x, d low, which is 4 times 2x, all over 4x squared. So we end up with what? A 4x squared, I should say negative 4x squared sine x, minus 8x cosine x over 16x to the fourth. And we could reduce 4 out of all this to give us a negative x squared sine x minus x cosine x over 4x to the fourth. Okay. Okay, here's another one. Find the derivative of f of x equals x over cosine of x. So again, we have a quotient rule problem. And so our derivative low, which is the cosine of x, d high, which is going to be 1, the derivative of the x is 1, minus high, which is the x, d low, derivative of cosine is negative sine, all over cosine squared x, the square of what's below. So f prime of x is going to be cosine of x plus x sine x divided by cosine squared x. Okay, let's go on to the next one. Particle moves along a coordinate axis in such a way that its position at time t is given by s of t equals 2 sine t minus t. What time is the particle at rest? So what we're going to do is take the derivative. So our velocity is the first derivative of position function. So derivative of sine is cosine, 2 cosine t minus, and the derivative of t is 1. So we're going to take this 2 cosine t minus 1 and set it equal to 0, because that's when the velocity is at rest. So 2 cosine of t equals 1. Cosine of t equals 1/2. So the question is, from 0 to 2 pi, when is cosine of t 1/2? That's when t is going to be pi over 3. And let me think, it's also fourth quadrant, so that's 5 pi over 3. Okay, same kind of thing here. Particle moves along coordinate axis and position at time t given by s of t is the square root of 3t plus 2 cosine t. So again, our velocity at time t is the first derivative of the position function, and that's going to be, so square root of 3 is a coefficient, so just square root of 3 times 1, and then we have plus 2, and the derivative of cosine t is negative sine t. So we have the square root of 3 minus 2 sine t. So we take that square root of 3 minus 2 sine t and set it equal to 0. So square root of 3 equals 2 sine t, and sine t equals square root of 3 over 2. So from 0 to 2 pi, when is that going to happen? Remember your trig days. And that's going to be at the first quadrant, so pi over 3, and second quadrant, 2 pi over 3. The derivative of the tangent function. Find the derivative of the tangent function. Okay, this will be interesting. So what is our tangent? That's going to be sine of x over cosine of x. So our derivative is going to be, again, low d high, so cosine of x is low. D high, derivative of sine is cosine, minus the high, which is sine of x. D low is the derivative of what's down below, that's cosine. Derivative of cosine is negative sine of x, all over the square of what's below, so all over cosine squared x. And so that's going to be cosine squared x minus sine squared x over cosine squared x. Oh, sorry, that's not minus, it's double negative, so it's plus. That gives us a 1 in the numerator, and that gives us a cosine squared x in the denominator, which leads to secant squared x. So now you know the derivative of the tangent is secant squared x. Now, what about the derivative of a cotangent? Same process. This is going to be a cosine of x over a sine x. So our derivative is going to be low, which is sine x, d high, which is going to be a derivative of cosine, which is negative sine x, minus high, which is cosine x, d low, which is going to be derivative of sine, which is going to be cosine x, all over sine squared x. So in this case, it's negative sine squared x minus cosine squared x over sine squared x. If you factor out that negative in the numerator, you have negative of sine squared x plus cosine squared x over sine squared x. So it's the negative of sine squared x plus cosine squared x is 1 from remember your Pythagorean identities for trig? 1 over sine squared x. So negative 1 over sine squared x, that's going to be negative cosecant squared x. Hey, look at that. We derived a couple more. That's great. Okay, so we have other things to look at. We derive the derivative of tangent, derivative of cotangent. Derivative of secant is secant x tangent x. Derivative of cosecant x is negative cosecant x cotangent x. So just remember this chart. It's probably useful to print it or put it on your note card or something where it's handy. Just you can remember these values of the different functions from 0 to pi over 2 or 0 to 90 degrees. It tells you what it's going to be. And if you recall from your trig days, these are cyclical functions, and so they start repeating themselves. Find the equation of the tangent line to the graph of cotangent of x at x equals pi over 4. Okay, so we have f prime of x is going to be, so we just said derivative of cotangent is negative cosecant squared x, right? And that derivative at pi over 4 is going to be negative cosecant of pi over 4, that amount squared. The squared applies f before this negative is applied. So it ends up being negative square root of 2 squared. So I get 2 out of that. Negative 2. The other thing we need is at pi over 4, f of pi over 4 is cotangent of pi over 4, which is 1. So we have the point pi over 4, 1, and the slope of negative 2. So now we go to our y minus y1 equals m times x minus x1. So y minus 1 equals negative 2 times x minus pi over 4. So y minus 1 equals negative 2x plus, double negative, negative 2 times negative pi over 4 is plus 2 pi over 4. I'm going to add 1 to both sides. Y equals negative 2x plus, I'm going to reduce that 2 pi over 4 to pi over 2 plus 1. Okay, got a few more examples. There's a lot of examples in this section. Not the biggest example set I've had. We're going to see in an upcoming section. Okay, find the derivative of cosecant x plus x tangent x. So we're going to use the product rule in the second part. So our derivative is going to be, derivative of cosecant x is negative cosecant x tangent x, or it's cotangent x, excuse me, plus, now the product rule, derivative of x is 1 times the tangent x, plus the derivative of tangent x is secant squared x. So it's x times secant squared x. So it doesn't clean up a whole lot, really at all. It's negative cosecant x cotangent x plus tangent x plus x secant squared x. Okay. Okay, same thing here. Our derivative is going to be 2 times derivative of tangent x is secant squared x. And derivative of cotangent x is negative cosecant squared x. So you get 2 secant squared x plus 3 cosecant squared x. That's it. Find the slope of the line tangent to the graph at x equals pi over 6. So it's f of x equals tangent x. So f prime of x is our secant squared x. So f prime at pi over 6 is going to be secant of pi over 6, and we square that quantity. So let's see. For pi over 6, secant of pi over 6 is going to be 2 over the square root of 3. We square that to give us 4/3. Okay, let's try this next one here. It says if f of x equals 2 tan x over x, then f prime of x equals what? Then f prime of 4 is what? So I'm just going to do it over here. Our f prime of x, it's a quotient, so the quotient rule applies. Low, which is x, d high, which is going to be 2 secant squared x, minus high, which is 2 tangent x, d low, which is 1 over x squared. That's about it. So I'm going to write here x, 2x secant squared x minus 2 tangent x over x squared. Okay. So our f of 4, f prime of 4, I just plugged in the calculator, make sure it's in radian mode. 1.7616 39481. And that's it. Okay, we have another part of this doing higher order derivatives. So fun stuff.